Let's do the next question. In the given circuit, the switch is closed at time t is equal to 0. Determine V of t. Okay. So here, like I said, like I said, there are this every circuit with a switch. Just think of it like it has two circuits in it. One is when the switch is in one position, the other is the switch is in the other position. So here there is a circuit when the switch is open, and there is a circuit when the switch is closed. Okay, and here they are saying that the switch is closed at time t is equal to 0, which means before time t is equal to 0, the switch was open. Okay, that's what the sentence means. The switch is closed at time t is equal to 0, and after time t is equal to 0, that is starting from t is equal to 0, 1, 2, 3 and on, the switch was in the closed position. But before time t is equal to 0, the switch is open. Okay, see, like I said, there's another way of representing at time t is equal to 0. I can say like this: at time t is equal to 0 minus is also another way of representing that it represents the time t just before 0. Okay, that is what this actually means, just before 0. The time gap is very small, but still it is just before 0. That is what this sentence actually means. Okay, at time t is equal to 0 minus. Okay, so why I'm writing this time t is equal to 0 is because according to the sentence, the switch is open before time t is equal to 0. Only at time t is equal to 0, and after that only the switch was closed. So before that it was open. So which means whatever the switch the position was, the other position was supposed to be in the steady state condition. That is, at time t is equal to 0 minus, the steady state condition is achieved. Okay, because what this question, okay, this question is very simple, but you have to understand the meaning behind this question. What this question actually means is that when you walk into the lab, okay, and this circuit was actually in the open position for a long time. Okay, the switch is actually in the open position. The switch was actually open for a long time. Okay, it was open for a long time. That is what the steady state condition means. The switch was open for a long time. At time t is equal to 0 minus, the circuit was open for a long time. Okay, that is why it's called as the steady state condition. Okay, and when you walked into the room, when you walked into the lab, and when you close the switch, okay, when you close the switch, that is what happens at time t is equal to 0. Okay, so therefore the steady state condition is when the switch is open. Okay, that's a steady state condition. We all know that for a steady state condition, the inductors act as a short circuit and the capacitor act as an open circuit. Why are we writing the steady state condition? Why are we trying to find the value of capacitor? Why are we using the steady state condition? We are using this steady state condition because inside, when you are trying to find the Laplace transform of the capacitor, when you are going to apply the Laplace transform of a capacitor, we know that the Laplace transform of a capacitor is given by an impedance along with a positive voltage, right? An impedance along with a positive voltage. That is how we represent the capacitor. And this capacitor, right, over here, we represent this capacitor over here as 1 by Cs. The impedance over here is 1 by Cs, and the value of this voltage is, if you all remember, it is given by V of 0 by S. This is the voltage. So where V of 0 is the initial voltage across a capacitor, and you are trying to find, or you need to find, the value of V of 0. That is why you are applying the steady state condition. That is why you are trying to find the value of the circuit at time before 0. Okay, because you are trying to find this value over here. That is why you are doing this portion. Okay, so at time t is equal to 0 minus, which means the circuit was open. So if it was open means, what is the meaning of that? What does it mean? It means open means then the circuit will become like this, right? It's open. It's open. Open means this is open. Okay. This is open means there is no gap over here. Okay. There's no gap over here. That's it. Now you will be wondering what happened to the other capacitor. Look over here. This capacitor has been replaced by an open circuit, and this V of 0 is the initial voltage across the capacitor which you need to find. That is why you are using this condition. What about the other capacitor? Since the switch was open, this part of the circuit becomes open, which means no current will flow through this part. That's why this part has been removed, which means the initial voltage across this capacitor will be 0 itself. Okay, that's how it is. That's why it is open. So all you need to do is simply find the initial voltage of this capacitor. Okay, so this capacitor has been opened because under steady state condition the inductors will act as a short circuit and the capacitors act as an open circuit. So this capacitor will become open over here, and you need to find V of 0, which is the open voltage across these two ends, which is the initial value. This is what you need to find over here. So let's find the value. So in that case, to find the value of V of 0, we all know that V of 0 is nothing but the voltage across the 2 ohm resistor, right? It's the voltage across the 2 ohm resistor. Okay, anyway, let this be I1, let this be I2, but I2 is equal to 0 because this mesh is open, right? But anyway, I2 is equal to 0, I2 is equal to 0, I write like that, I2 is equal to 0 because this mesh is open. So in that case, the equation will be, here it will become I1 into 2 plus 2. I1 is equal, I1 into 2 plus 2, it will be minus 2I2. 2I2 is equal to 4, but I2 is equal to 0 because this mesh is open. So therefore you get I1 is equal to 1 ampere, right? You will get I1 because 2 plus 2 is 4. So and this I2 is equal to 0. So I1 is equal to 1. And what about the equation for mesh 2? The equation for mesh 2 is minus 2I1, okay, minus 2I1 plus 2I2, right, plus 2I2 and plus V of 0 is equal to 0, right? Because here if you look over here, this is the higher potential, this is the lower potential, and I2 is flowing from a higher potential to a lower potential. That is why I marked it as V of 0. But this mesh is also open, therefore I2 is equal to 0. We get V of 0 is equal to 2I1, but I1 is equal to 1, therefore V of 0 is equal to 2 volt. So therefore V of 0, or the initial value of this capacitor, the initial voltage across the capacitor is 2 volt. Okay, that is when the switch was open, right? I can write that also. Now next I am going to apply at time t is equal to, at time after time t is equal to 0, which I am going to write at time t is equal to 0 plus. Okay, what does this statement means is that this statement is that the after time t is equal to, just after time t is equal to 0, and it says that the switch is closed at time t is equal to 0. That means at time t is equal to 0, and after that the switch is in the closed position. So if it is at the closed position, then the circuit will become like this. That is, it will be having a voltage source over here, and a resistor over here, and the resistor over here, and a capacitor over here, and this switch is the closed position, so it's closed, and then there will be another capacitor over here. Okay, this is the circuit, right? And this is 2 ohms, this is 2 ohms, and the value of the capacitor is 1 Faraday. The value of this capacitor is 1 Faraday, and this is 4 volt. Okay, so this is at time t is equal to 0 plus, where the switch is in the closed position. So now your job is to find this V of t. What is V of t? V of t is the voltage across this capacitor. V of t is the voltage across this capacitor, this one right here. Okay, this is what you need to find. So now I'm going to apply the Laplace transform to the circuit. Therefore, the transformed impedance so transformed impedance means this is a voltage, and the Laplace transform of 4 is 4 by S. The Laplace transform of a resistor is that resistor itself, which is 2. The Laplace transform of this resistor is also the resistor itself, which is 2. The Laplace transform of the capacitor, we all know that the Laplace transform of a capacitor is a capacitor in which its value is 1 by Cs, and also it has a positive voltage whose value is V of 0 by S. Okay, so here the value of C is 1. The value of C is 1. So it is, so which means this is nothing but, let me draw that, a capacitor with a positive voltage. Okay, and over here the capacitor is 1 by Cs, which is 1 by S. Okay, and the positive voltage V of 0, value V of 0 is 2. So the value of this positive voltage is 2 by S. The value of this positive voltage is 2 by S. Okay, and here we have a capacitor whose impedance is also 1 by Cs, and here C is 1, so it will become 1 by S. And this capacitor does not have any initial voltage because on the steady state condition this circuit was open, right? If this circuit is open, then this part of the circuit is also open, or this capacitor is open, which means there is no initial current through this capacitor, which means there will be no initial voltage across this capacitor. That is why this capacitor is alone. Okay, this is the circuit. So here they ask us to find the voltage across this capacitor, which is V of S. Let me mention it as V of S, where V of S is the Laplace transform of V of t. V of S is the Laplace transform of V of t, and V of t is the voltage across the capacitor. Or this V of S is the voltage across this impedance, which you need to find. Okay, so let's find the impedance. So here, let this be I1 of S, let this be I2 of S, and let this be I3 of S. Okay, so I need to find the value of I3 of S, right, in order to find the voltage across the capacitor over here. So it's a very simple question, right? So let's do this. There's I1 of S into, we have let me see, we have 2 plus 2, right, which means we have 4 over here, minus I2 of S into 2, right, is equal to 4 by S. This is the equation. Okay, maybe I can should I simplify this? We'll see whether we should simplify that. Maybe I can divide this by 2 or something, just to make it more simple. So it will become I of S into 2 minus I2 of S is equal to 2 by S. Okay, dividing this entire equation by 2, you will get this equation. Okay, so this is the equation for mesh 1. Let me write that also. Equation for mesh 1. What about the equation for mesh 2? Equation for mesh 2 is given by, let me see, here it will be minus I1 into S into 2 plus I2 of S. I2 of S is equal to, what it is it let me see, 2 plus 1 by S, right? 2 plus 1 by S. Okay, 2 plus 1 by S minus, and we have I3 into 1 by S I3 into 1 by S is equal to minus 2 by S, because this current I2 is flowing into the positive terminal, right? So therefore it is minus 2 by S. Okay, this is the equation for mesh 2. Okay, is it possible to simplify this equation? Maybe I can simplify this equation, right? Because I already know that I of S into 2 is this one. So which means to simplify it, I can simply write this as nothing but, I can simplify this, right? This is nothing but minus of this, right? So what I need to do is simply write, this is I2 of S into I1 of S into 2 is 2 by S plus I2 of S. 2 by S plus I2 of S, which means minus I of S into 2 is minus 2 by S minus I2 of S plus 2 I2 of S plus I2 of S by S minus I3 of S by S, okay, is equal to minus 2 by S. So minus 2 by S and minus 2 by S will cancel each other. Very good. And what else can we do? What are the magic else we can do? We can write over here, this is I2 of S, right? Minus I2 of S plus 2 I2 of S is I2 of S plus I2 of S by S minus I3 of S by S is equal to 0. Or I can say that I2 of S, I'm not going to write I2 of S every now and then, I'll just simply write I2 itself, okay? So I2 into S plus 1 by S, okay? I2 of S, okay, I write I2 of S, otherwise, because it's a Laplace transform, right? So I2 of S into S plus 1 by S minus I3 of S into 1 by S is equal to 0. Okay, this is one equation. Okay, let's see if we can do some other magic with this equation when we look at the equation for mesh 3. So what is the equation for mesh 3? Equation for mesh 3 is given by, let's see, it is minus I2 of S by S, right? Minus I2 of S by S plus I3 of S, right? Plus I3 of S. What about I3 of S? It will be 1 by S plus 1 by S is 2 by S. I3 of S into 2 by S is equal to, and this current I3 of S is coming out of this, right? It's coming out of this positive voltage, right? So therefore I can say it is 2 by S plus 2 by S. So it is just 2 by S over here. Okay, very easy, no? This is very easy. So now I can, oh yeah, it's very good, no? So now I can replace this. We know that I3 of S, I3 by of S is nothing but, let me see, it is I3 of S by S, right? I3 of S by S, or I can, no need, I'll write this, I3 of S into 1 by S is equal to, let me see, it is this one, that is I2 of S into S plus 1 by S, right? So which means I can substitute that over here. So I will get over here minus I2 of S into 1 by S, and this is replaced with, this only has a 2 over here, so it will become, this is nothing but plus I2 of S into 2S plus 2 by S is equal to 2 by S. Very good. So which means that S and S will cancel each other, and then this will become minus I2 of S plus I2 of S into 2S plus 2 is equal to 2. And in that case 2I of S minus I2 of S, yes, 2I2 of S minus I2 of S is I2 of S. So this will become I2 of S into 2S plus 1 is equal to 2, or in other words, I2 of S is equal to 2 by 2S plus 1, or you can also take it, if I take 2 common out, it will become 2 by 2 of S plus 1 by 2, or this is nothing but 1 plus S plus 1 by 2. So I2 of S is equal to 1 by S plus 1 by 2. In that case, then what is I3 of S? I need to find the value. My job is to find the value of I3 of S, right? So I3 of S is I3 of S into 1 by S is equal to, and what is I2 of S? I2 of S is 1 by S plus 1 by 2, right? 1 by S plus 1 by 2. This is I2 of S into S plus 1 by S. This S and this S will cancel each other, so you'll be left with I3 of S is equal to S plus 1 by S plus 1 by 2. This is I3 of S. So if this is I3 of S, now I can find the voltage across the capacitor, that is V of S, right? Therefore V of S is equal to I3 of S into the capacitor, and the capacitor is 1 by S into 1 by S. This is the voltage across the capacitor, which is S plus 1 by S into S plus 1 by 2. Okay, this is the equation. So what I need to do is simply find the Laplace inverse of this. Very easy, right? So therefore the here S plus, so therefore V of t, okay, V of t is equal to the Laplace inverse of S plus 1 by S into S plus 1 by 2. Okay, and what is the Laplace inverse of this? You need to partially factorize this first. So S plus 1 by S into S plus 1 by 2 is written as A by S plus B by S plus 1 by 2. So what is A? What's the value of A? A is, first look at the denominator of A, remove that denominator from here. So if I remove here, the denominator of A is S. So remove S from here, write the remaining answer, S plus 1 by S plus 1 by 2. And then you replace S is equal to 0. So this will get, you will get 1 by 1 by 2, which is 2. So the value of A is equal to 2. Now I'm going to find the value of B. So to find the value of B, B is equal to, look at the denominator of B. The denominator of B is S plus 1 by 2. So remove S plus 1 by 2 and write the remaining values. It will become S plus 1 by S. And then you substitute the value of S is equal to, see, S plus 1 by 2 is equal to 0. So therefore S is equal to minus 1 by 2. So therefore S is equal to minus 1 by 2. And you will get over here as minus 1 by 2 plus 1 by minus 1 by 2. And this, you will get over here as this is 1 by 2 by minus 1 by 2, which is equal to minus 1. So therefore B is equal to minus 1. B is equal to minus 1. So therefore S by S plus 1 by S into S plus 1 by 2 is equal to, A is equal to 2, right? So it is 2 by S minus 1 by S plus 1 by 2. S plus 1 by 2. Therefore, the Laplace inverse of S plus 1 by S into S plus 1 by 2 is given nothing but the Laplace inverse of 2 by S minus the Laplace inverse of 1 by S plus 1 by 2. Okay, or in other words, what's the Laplace transform of 2 by S? It is 2 into U of t, minus what is the Laplace transform of this? Is nothing but e raised to minus 1 by 2 into t, or minus t by 2 into U of t. Okay, this is the Laplace inverse. So therefore V of t is equal to 2 U of t minus e raised to minus t by 2 into U of t, or in other words, it is 2 minus e raised to minus t by 2 into U of t. This is the voltage across the capacitor. This is your answer. Okay.